Now, although we can see the Andromeda Galaxy in the night sky, that's pretty much the only galaxy visible to the naked eye in this hemisphere. But there's much more on offer in the southern hemisphere, which is where Liz Bonin is standing by for us right now.
Thank you very much, Dara. Welcome to the Southern African Large Telescope in the middle of the Karoo Desert. The weather has been rubbish again here today, Dara. What can I tell you? Murphy's Law. But it looks like it might be clearing up, which is why the SALT telescope is moving into position, getting ready for a night of observations. Now, there are two galaxies that are visible to the naked eye down here. They're actually closer to us than Andromeda. And a couple of nights ago, I went galaxy gazing with some budding astronomers from the nearby town. In the middle of the Karoo Desert, about 200 miles northeast of Cape Town, lies the tiny town of Sutherland. Before the South African Astronomical Observatory relocated here in the mid-70s, this was just a small farming community with a few hundred people. And you show me where you live. You show me where you live. But now, Sutherland is home to one of the largest telescopes in the world, and that has made it something of a tourist destination. And astronomers are also keen that the whole community understand just what a special stargazing spot this is. Anthony Metis runs the observatory's outreach program.
Okay, so what's happening with these kids this evening? You take them out to fly kites. Why?
Liz, one thing about the kites is you have to look up. It's a way of exposing them to the night skies.
So as the sun begins to set and the stars come out, they'll change their attention to...
They'll change their attention to what's happening. Sometimes we're lucky and we get a shooting star, and immediately somebody will ask, what just happened up there? You know? And we have actually one of the astronomers down here, David Gilbank, will be talking to the kids about galaxies later on as well.
A good way to describe a galaxy is as a city of stars. So basically our Milky Way is all the stars that belong to our star city. If we could see our galaxy from the outside, what we'd actually see would be something that looks like the shape of a dinner plate, something that looks like a disc like this. So we actually live about 2/3 of the way out from the centre. And so when we look up at the night sky, when we see this thick band, we're actually looking into the thickest part of the stars as if we're looking through the edge of the plate.
How many stars are in our Milky Way?
It's a good question. So there are about 100 billion stars within our own Milky Way galaxy. So that's a 1 with 11 zeros after it.
What is the closest galaxy to our own Milky Way?
Okay, so the nearest galaxy that's about the same size as us is called the Andromeda Galaxy, but there are actually lots and lots of much smaller galaxies in between. So if you look up here, you may be able to see that there's kind of this misty patch of light here, which kind of looks like a small version of the Milky Way.
Yeah. Can you all see that?
So this is called the Large Magellanic Cloud. And this is actually a satellite galaxy of the Milky Way. So in the same way that the Moon is a satellite of the Earth and orbits around us, the Large Magellanic Cloud is a satellite galaxy of the Milky Way and orbits around us. So what you're looking at through the telescope is actually, it looks like a bright patch within the LMC, and this is something called the Tarantula Nebula. It may look like little tendrils, like legs of a spider. This is a big cloud of gas in which stars are being born right at the moment. You can also see that there are new young stars in the LMC by looking around it, by looking at we see lots of bright blue luminous stars.
So new young stars are blue.
Yes.
Why is that?
If you think about, for example, the taps on your sink at home, you have blue being cold and red being hot, and it's exactly the opposite in astronomy. So the way to think about this, if you imagine taking a piece of iron and putting it into a fire and heating it up, it'll start off glowing red hot. So that's the coolest you could possibly get. If you heat it further, it will eventually start glowing white hot. And if you could heat it hotter without the metal melting, it would eventually glow blue hot. So blue is the hottest type of star, and red are cooler stars, but still very hot. So I can show you what I mean. Okay, so this is the LMC that we've just been looking at.
And that's the Tarantula Nebula there?
That's the Tarantula, yep. These very hot, very bright stars burn up their fuel very fast, so they don't stay around, they don't live very long. And so if you see these hot blue stars in a galaxy, you know that they've been put there recently, so they know that it's forming new stars. However, if there's no new star formation going on, then you'll only see these older, longer-lived stars which appear red.
And they're red because they're older.
That's right, yeah.
So what is it that stops star formation in galaxies?
So we know that in order to form stars, we need these nebulae, these star-forming regions, these clouds of gas. So we know that something must be removing the gas or preventing it from forming stars in some way. But we don't know exactly what that is, and this is one of the things that I'm trying to answer and work that I'm starting to do here with SALT.
And there is also a small Magellanic Cloud in the southern hemisphere. In fact, SALT altered its fixed viewing window to be able to observe it in its entirety. And it's below the large cloud, a little to the right. It's got about 1/10 of the stars of the large cloud, and it's actually more elongated than the large one. It's just that we look at it head on from Earth. Now, David, the Magellanic Clouds are part of this local group of galaxies. What is a local group?
So the local group's the name that we give to the collection of all nearby galaxies that are bound together by gravity. So the local group consists of 3 main big galaxies, including the Milky Way and Andromeda, and maybe several dozen smaller galaxies like the Magellanic Clouds and smaller.
Okay, and you've been taking part in a survey that's attempting to find out how many galaxies there are out there in the universe. You've looked at just 3% of the sky. What have you found so far?
So we're mainly looking for clusters of galaxies, so associations like the local group and larger. And so far we've found about 30,000 galaxy clusters, and each of those clusters contains maybe tens to hundreds of galaxies.
That amounts to already 3 million galaxies in just a tiny speck of the sky. Galaxies are everywhere that you look, and apparently they're distributed across the universe in a great cosmic web of filaments, and astronomers are only just beginning to understand what that might look like. Now, join me later when I find out how galaxies grow. Apparently the Milky Way is in for a bumpy ride.